Okay, so in this video we're going to look at how we can use a displacement shader to add to the overall believability of our existing HDRI shader. Now please note this is not a detailed discussion on displacement. That could easily be a DVD all on its own. This is just a quick look at how we can add some basic displacement to our shader. And so far we've been dealing with a single surface shader for defining our HDRI material. So we've got our material. So you could think of this as being our material. And inside that material we've got a surface shader. And we know that the output of that shader is wired into the output of our material. And we know that this surface shader has been defining the color of our final render, because for every pixel that we're rendering, we evaluate this surface shader and we pass it in a series of information about the point that's currently being rendered, and that allows us to determine the color of that point. We're passing in information such as the position, the surface normal, UV information, and the likes. We're passing in a lot of information, and all of that information is being taken and used to determine the color of the point as we're rendering it. So it's actually determining the final pixel color in our image. We can augment our material by adding a displacement shader alongside our surface shader. So if we were to add a displacement shader alongside our surface shader, this is going to augment our material, if you will. And the way we can think about this is that we've just said we've got this information that's being passed into our surface shader, and that is determining the final rendered color. The information such as the position of the point and the surface normal of the point are very influential in determining the final color of the pixel represented by that point on the surface in our final render. The displacement shader can be thought of as modifying the properties of the point that we're rendering before passing them over to the surface shader. And thus, if we're modifying those properties, we're going to be modifying the final rendered color of the point. Now specifically, in a displacement shader, we can modify the position, so that's the P variable, and the normal of the point that's being rendered. And this is very useful to us because by modifying the position and the normal of the point being rendered, we can basically add a lot more detail to our geometry than is present with just the geometry itself. So let's look at a really simple example where we have just a single face. So if we had a single face in Houdini and that face got sent out for rendering, we know that when we're rendering with just a surface shader, we can't add any more detail to this face. We can add various color information in terms of texture maps applied to this face, but we can't add any more detail. And if we wanted to modify this face, we could only modify it at the geometry level back in Houdini by moving its 4 vertices. And by moving those 4 vertices, we would be modifying that face. That face would then get sent out for rendering, and when it comes to rendering, we would evaluate our surface shader for each of the points on that face that we're rendering. However, now if we're using a displacement shader, we can alter the position and the normals of every single point that we are rendering on this face. So that means as we're rendering points on this face, we can say, well, actually this point doesn't exist here. Let's displace it and move that point up here. Or what about this point? Let's displace it and move it up here. This guy can move up here. Maybe this guy can move over here. And that would give us a bump on our surface. If we thought about that traveling in the other direction as well, we'd get another bump. So we can imagine that we've added a bump to our surface, something that we just simply couldn't do with the detail that we had with just the face alone back in Houdini, back with our geometry context. By adding this displacement shader, we've added a bump to our geometry. We've added more detail to our geometry because we thought of each point we're rendering as being displaced from its actual position. We've moved that point. We can also affect surface normals so that we get shading that represents this new definition in our shape, and that's allowed us to add a lot more detail at render time. And this is really important because the more detail we can add, the more realistic, in quotes, the end result's going to be, because it's all about detail. If we have lots of small details in terms of our texture maps, in terms of our displacement, in terms of how our reflections are working, all of those details combine, and the end result is something that has a lot of visual information, which the more visual information we have, the more likely a viewer is going to believe it as being real, because everything in the real world consists of so much visual information. There's always lots of details, and the key to making anything look realistic is attention to detail, looking at the real world, looking at what it is we're trying to recreate or something similar, because chances are 9 times out of 10 what we're creating has some basis in the real world, and looking at how in the real world, what are all the details, all the small little details that are what make that object unique, what make that object believable. And then if we can recreate all of those small details when we're working in 3D, working in Houdini with Mantra, that's going to allow our rendered result to be as believable as possible. So the key really is in details, and displacement mapping allows us to add a lot of detail at render time. And the simplest form of displacement mapping allows us to simply use an image to push and pull our surface in the direction of the normal. So we could think of mapping an image based on our UV coordinates onto this face, and then where the image is white, we'd pull the face out along its surface normal, and where it's black, we'd push it in on its surface normal. And that's a really simple form of doing displacement mapping. And there's a VOP available to us that allows us to do such displacement mapping. There is a displace along normal VOP, and this VOP allows us to specify an amount we wish to displace for the point we're rendering, positive values going in the direction of the surface normal, negative values going against the surface normal. And if we were to take a texture and use UV coordinates to work out a value from a texture and feed that into the amount we want to displace, we can then use a texture to displace our surface. The nice thing is the displace along normal is going to output a modified position and a modified normal vector for the point that's being rendered. We output that from our displacement shader, and those get fed into our surface shader, so that the surface point that we're rendering has now been modified. It's been moved in position, its surface normal's changed, and that's going to affect its visual properties. And that pretty much sums up the concept of displacement. Now we are going to encounter some render properties relating to displacement that allow us to instruct Mantra on how we want to deal with some of the more technical aspects of displacement shaders, and we will discuss those briefly when we encounter them. But this is the basic principle. The basic principle is we have the ability to modify the position of the point we're rendering and the normal of the point we're rendering, and obviously that's going to affect both the amount of detail we see on the scene, or on the screen rather, but it's also going to affect those variables that are getting passed into our surface shader. And we know that normal has been integral to how we're driving our shader, because it's used for ambient occlusion, it's used for determining how reflection works and what the reflection vector would be, which is used for our environment lookup. The normal is used for the diffused lighting environment lookup. The surface normal is so key to everything we're doing in our shader that if we're affecting this with a displacement map, we're going to be heavily affecting our final rendered color, and that's going to allow us to add a lot more detail into our geometry. So that's a quick look at how displacement works at a sort of overall level and how it's going to help us with our material. In the next video, we'll implement this very basic displacement shader. Thanks a lot, everyone.